Good afternoon, everyone. My name is Mckay, and I'm a member of the engineer and marketing team here at Buckley Associates. Before we start the webinar, I would just like to say a couple of words here. To start, thank you to everyone participating today for taking some time out of your day to spend with us and learn about safe and effective clean air distribution with UV and bipolar ionization. It means a lot to us here at Buckley, and a lot of effort really goes into the planning of these webinars, and we're happy that you see a value in the services we're kind of providing to the engineer and contractor community here in the Northeast. The speaker today and the presenter will be Keith Mckay. He's a national sales manager at Big Ass Fans since 2000. Well, he's been at Big Ass Fans since 2012. He's had a couple of roles there: industrial sales associate, national accounts, and he's currently serving as the national sales manager for Big Ass Fans. The topics that we're going to discuss today, that he'll be discussing, are ones that the entire engineering team at Buckley are very familiar with at each location. We deal with these systems daily, and we're here to help. We have over 10 mechanical engineers supporting Northeast market for design, application, and solutions on all of Buckley applied and engineered products. If you have any questions following the webinar, or you're working on a project that currently has the current topic, please reach out to myself or your local Buckley rep. If you're not sure who the Buckley rep is in your area, please reach out to Sherry. She'll get you in touch with the right person, whether it's this topic or any other. And now, kind of like the movie theater, we have quite a few people registered for the webinar today. All of you will be muted during the webinar to kind of keep things running smoothly. If any questions come up in the webinar, I know we're going to have a couple of breaks in between to ask if anybody has any questions. Feel free to use the chat function. This will enable, we get these questions up and he can concisely answer for you. Now that we're ready to go, I'd like to turn this over to Keith, let him start the webinar, and thank again the entire engineering and marketing team at Buckley. And Keith, thank you for being the presenter with us today.
Likewise, thank you for having us. We always appreciate the opportunity to get in front of Buckley's clientele, and you guys certainly represent Big Ass Fans extremely well. So I'm also joined by two of my colleagues, senior applications engineer, among many other things, Christian Tabor, and our field expert based in the Northeast, Lane Finley, who works very closely on an hourly basis with the Buckley team. So we'll keep the introduction very short today. What I'm going to do, or make a promise to you, is that we're going to leave no less than 10 minutes on the end here. This kind of topic is something that I hope makes you want to ask some questions and learn more. If you're here and spending a part of your day to learn more about this stuff, hopefully it means that you're doing research on these kinds of topics. And I can guarantee you I won't give you all the answers today. So whatever questions you have, let's ask them in real time using that chat feature, or I will leave no less than 10 minutes on the back end so we can address those questions. Today, I want to cover 5 things at a high level, most of them at least. Number one is the 2 disinfection sort of technologies that we have harnessed as a part of our world-leading HVLS, directional, and residential commercial ceiling fans. We're going to talk about a universal measuring stick, if you will, on how to compare the effectiveness of some of these technologies. And I'm going to make a specific attempt to help you all help your customers, even without Big Ass Fans being the product of topic, how to get them to understand sort of what they're looking at, how to compare one investment to another investment, and how to compare those investments to the sort of effectiveness of the various options they're looking at. Luckily our systems are extremely effective, so it always works out for Big Ass Fans when people are comparing the efficacy or the performance of what is being quoted to them. But I want to give you guys some universal language there that hopefully you can drive to your customers. We're going to talk about upper room GUV, germicidal ultraviolet light, since we have integrated that into a couple of our products thus far. And we're going to talk about bipolar ionization and the application of those two technologies in the spaces where we can make a huge impact. And then last but not least, we're going to sort of put our money where our mouth is by showing you real world examples. These are installs that have been completed for some time now. We've gone back. We've actually completed studies, whether it be ion concentration, airflow, what have you. I will show you those at the end so that you know everything I'm going to show you in the beginning is not just theory. It is sort of the pre-work to what we can show you we can accomplish in real life. And everything that you can see today will be available after the fact, and there are no secrets. So without further ado, we are going to talk about two technologies when it comes to what Big Ass Fans has done. On our larger fans and on some of our directional portable fans, we're using needlepoint bipolar ionization. It's not a technology Big Ass Fans invented by any means. Ionization has been around for quite some time. In a residential setting, ionization devices have been used to pull pet dander, mold, dust mites, pull them out of the air, weigh them down and get them down into the carpet where the vacuum cleaner can suck them up, keeping them out of the respiratory zone, or increasing particle size so that they can, those airborne particles can be caught in a filter in your HVAC system that may not be a MERV 13. You know, it essentially increases that particle size so they are easier to catch. Ionization has two benefits in an industrial setting, or as we've applied them. One, we can put out positively and negatively charged particles. They will go out there and find things in the air, find them and stick to them. And then as they clump together, they increase the weight of that, just like they did in people's homes, you know, in the old school version of ion devices. The good news, though, is they also have a biological effect, and that biological effect is germicidal, and we have proven that it is able to kill SARS-CoV-2, among other things. And I will show you those third-party test results here in a moment. So what you can do with an ionization product from Big Ass Fans is you can either use it on a portable device, like a portable a portable fan, directional fan, and you can distribute ions at the breathing zone on, for example, a manufacturing line, a pick pack line in a distribution center, a small fitness gym, or you can use an overhead product that is, you know, 12 to 24 feet in diameter, and you can distribute a high concentration of ions over a very large area. Once again, inactivating airborne pathogens, among many other benefits in the breathing zone in an area, you know, potentially up to 200 by 200. The second technology is much more widely known and has a lot of history, almost a century, or actually more than a century of history in the scientific and medical communities, and it's ultraviolet light. More specifically, we are using what's called UVC. UVC is a wavelength that is significantly safer for human beings. It is not UVA or UVB, which are longer wavelengths and have the ability to penetrate human skin. So UV, what it does is a little bit different. It doesn't put out any ions, but it actually scrambles the DNA and RNA sequence of the virus or viruses, and it prevents them from replicating. Once you prevent a virus from replicating, it can no longer find a host and you know, exponentially duplicate itself, and therefore it's harmless. So we're going to use a ceiling fan to control the airflow. We're going to bring those particles up to the UV, what's called the UV kill zone, and we're going to inactivate airborne viruses, including SARS-CoV-2. Both of these systems, if designed appropriately, can significantly increase the safety of the air in an indoor environment. Most of our designs typically achieve 88 to 95% risk reduction when it comes to airborne pathogens being transmitted from one person to another. And what I hope you take away from today's presentation as well is that these solutions are significantly more cost effective than if you were to attempt to achieve the same sort of ventilation dilution or pathogen reduction with outside air. If you talk about DOAS units or other means of pulling in fresh air to try and achieve the same rate of disinfection that we can achieve with our products, typically we are on several orders of magnitude cheaper as far as upfront cost and ongoing cost than trying to accomplish the same result with HVAC. All right, one thing I would encourage you all to do and you encourage your customers to do is ask for third-party validation. It's sad, but there's a lot of COVID hustlers out there, and they're out there trying to sell things on Amazon, and they're out there pushing things that have absolutely no scientific backing, no third-party validation. But in a modern world where you can build a website in 10 minutes and say whatever you want before the police come and take you down, there's a lot of people out there sort of preying on people looking for a solution. So I would encourage you guys to ask for third-party test results and ask your customers to do the same. What I'm showing you now is going to be 3 tests conducted at Innovative Bioanalysis, a biosafety level 3 lab in California, which means they have the people, processes, and facilities to work with pathogens that are deadly to human beings. And this is the result of our ionization test, one of hundreds of tests that we are running or have run already with the Innovative Bioanalysis team. What you see is a chart that shows inactivation of actual SARS-CoV-2 that was aerosolized to an extreme extent in a room or put into surface or sort of petri dishes where they can grow. And you're seeing the effect of what's called 40,000 ions per cubic centimeter over time. What you can see is that at the 60-minute mark, we achieved what's called a 5 log reduction, which is 3 places past the decimal, 99.999% reduction when we have 40,000 ions per cubic centimeter in this test setting. So your takeaway from that should be very simple. Do air ions have an effect on SARS-CoV-2? Do they inactivate SARS-CoV-2? And the answer is objectively yes. We are not the only company who has proven that air ions can inactivate SARS-CoV-2. So make that be a takeaway for you. Air ions are proven to inactivate SARS-CoV-2. Yes, there are 100 variables in play. How many ions you have, how well are they distributed, how long do they last? All of these things are things that we will do and talk about as a part of our design process as we help you all and your customers understand what the best option for them is. Yes, we achieved 5 log reduction at the 60-minute mark in this example, but I want you to really focus in, if you can see my mouse, right here between the 0 and 10-minute mark. What that basically says is the air ions have an immediate and rapid impact, reducing this high concentration of SARS-CoV-2 by 50% or more in the first 10 minutes. That actually is just as powerful information as knowing that at the 60-minute mark we were able to completely eliminate it. This is an option here if we design it well with you, where you can tell your customers if a person was to come into this room and sneeze, SARS-CoV-2 out into the air, that this ionization system will immediately and drastically reduce the amount of sort of living virus particles in the air or on surfaces in the form or in the realm of ionization. Okay, the second test was similar. This was using our directional fan, which is also an ionization product, and you can see the same thing. You can see a 5 log reduction within the 60-minute time frame, and you can see that in the lab box over here, you can see that it was our product. It was called the Air Eye fan with the bipolar ionization device on the front of it. And you can actually see what it looks like compared to control with the fan on, with the fan off, and we can go over all of this with you. Your takeaway here is a second example of air ions inactivating SARS-CoV-2 in a real world application. The last study was on the UVC. Again, UVC was not invented by big ass fans and it's not proprietary to big ass fans. However, we have implemented it onto the top of a ceiling fan, which makes it an upper room GUV system, which I'll talk about here shortly. And the results on your screen show objectively that that system is able to inactivate SARS-CoV-2, among many other things, which we'll talk about as well, in a very rapid amount of time. Once again, look at the chart between the 0 and 10-minute mark. You can see well over a 50% reduction in SARS-CoV-2 just within the first 10 minutes. You can see 20 minutes, we're at 99%, and at 30 minutes, we're at 99.99%. So all of these options that we're showing you today are validated by a third-party biosafety level 3 laboratory in California, and that we have actually measured them against SARS-CoV-2, not a surrogate virus, not influenza, and we're not making correlations. We're telling you specifically, yes, we can provide documentation that these technologies can inactivate SARS-CoV-2. So why is Big Ass Fans a fan company? 21 years of designing and manufacturing high volume, low speed, world-class residential fans, super efficient and powerful directional fans. Why are we talking about disinfection? And the real answer is because there are several studies that prove that air movement is the difference between a low performing version of either of these two technologies and getting the absolute maximum that you could possibly get out of these two technologies. So I'm going to go over ionization first, and then we'll talk about UVC. So what is our advantage over other forms of ionization? There are really a couple things. Number one, the amount of ions that are generated from one of these ion generating devices, as you can see affixed to our winglet on the tip of the blade, is sort of directly correlated to how fast you can get air moving across those little needles. All right. By putting the bipolar device on the end of my fan, which could be up to 24 feet in diameter, I can get air that is 55 miles an hour running past those two needles. And that is actually very, very good, especially compared to other technologies that make promises about ion generation. Another benefit is I have 6 or 8 airfoils on one of my fans, which means I'm not limited to just using one device. I can put 6 or 8 devices on the fan, which means I can use every blade to generate ions at a high rate. So our first advantage is I have a lot of air moving past several devices, which means I can generate an extremely high volume of air ions. The second advantage is air ions, they only live, quote unquote, live for about 30 to 60 seconds. And basically all that is physics. They're highly charged positive and negative particles. And when you put something like that has a lot of energy out into the air, it wants to get back to neutral, which means it wants to find something that it can attach to. All right. So within 60 seconds in any indoor environment, those air ions are going to find something to stick to, whether it's a pathogen, a dust mite. By the time it makes it to the floor, it could stick to your shoes, it could stick to the wall, but it's going to find something to stick to in those first 30 to 60 seconds. The benefit of having ion devices on the actual fan itself is I am immediately delivering those ions that I just created straight to the occupants and the breathing zone. I'm not sort of wasting, quote unquote, any of my time, the lifespan of the ion, traveling through a catacomb of ductwork or traveling through other filtration devices. I am immediately distributing those ions, over a very large area. So those two benefits are really a difference maker, as you'll see when I show you the real world examples of why big ass fans knew that we had an extremely unique advantage in the air disinfection space. The second technology is UV, and more specifically, the application, since the product is integrated into our ceiling fan, is called upper room germicidal ultraviolet light, or upper room GUV. The punchline here is that fans are proven to increase the effectiveness of an upper room GUV system by 60 to 70%. And yes, we can provide all the documentation for the research conducted that proves this. So to be totally transparent, it doesn't have to be a big ass fan. A circulator fan is going to make an upper room GUV system more effective. So, trying to take my company hat off for a second, that is why this is so interesting to us, because by integrating the UV fan or the UV technology into the fan, it means that we know any time one of these solutions is designed, it's going to be as effective as it could possibly be, because the fan is taking control of the air and constantly mixing that air volume and bringing those particles up to the UV kill zone more rapidly and more effectively, inactivating airborne pathogens. So once again, air movement is the difference, and that's why we got into the air disinfection business. We are in control of the air. We understand air movement. We have for 2 decades now. So it's a very, very good fit, and they are highly effective options as you guys look out there for things that you can help your customers accomplish. So let's switch gears for a second. Let's talk about how do we measure the success of one of these proposed solutions for you, for your customer, for anything. I submit to you basically 2 forms of universal measures of success. And these, I would encourage you to think about these as your customers consider any option. If you think about these 2 things as a ruler, this should sort of even the playing field for everybody to be able to compare different investments, different options, different technologies. Number 1 is active and rapid. And what I mean by that is active means I can actually disinfect while the space is occupied. There are plenty of devices out there that are commonly used in hospital rooms where after the patient and the staff have left the room, you can roll in this cart that has a bunch of UV in a 360-degree pattern. Everybody leaves, you close all the curtains, and then you essentially zap the whole room with a high concentration of UV or high intensity UV, and it's known to essentially kill everything on surfaces and in the air. That is a great solution when you have the luxury of not needing to be in the room or not needing decontamination or disinfection while the space is occupied. The source of the SARS-CoV-2 and several other airborne viruses is the human being, right? It's the person that came into that room and potentially just now breathed out something that could be, deadly to somebody else. So active, I want your takeaway to be, we should be encouraging in the right applications. We should be encouraging our customers to make sure that they're looking at options that work while the space is occupied. The second one is rapid. The chart on the right gives you an example of how long it takes for a typical building with 2 to 4 ACH, assuming 99% efficiency, to take a particulate that may have just been breathed out of somebody's respiratory system and essentially exhaust them out of the room. 138 minutes, in my opinion, is a very long time and probably not fast enough if I want to look at my customers, look at my teachers, my students, my parents, and say, we've invested in something that is, very effective at making sure that the room or the air in the room is sort of scrubbed and reduces everyone's risk. 2 hours of giving that virus the ability to find just one other person's respiratory system in our opinion, and and everyone's opinion, I think, is just not long enough, or just not fast enough. So the rapid part of this is, as I showed you in the beginning, a well designed system can have an immediate impact and can have significant reductions even in the first 10 minutes if you're using a UVC or our ionization solution. So I would consider those two to be the first two just prerequisites. But then this is where it gets a lot more universal. Safety is fundamentally based on how quickly I can exchange dirty air with fresh air. In today's world, that means pathogens. In 2019, it meant it meant CO2 and other things, so we can prevent sick building syndrome. But basically, most buildings are designed for one outdoor ACH. As I showed you on the chart before, it's going to take quite a while for that HVAC system to potentially find that virus and expel it from the room. As you can see on the bottom left of your screen, if I can install a highly effective disinfection system in the room, I can achieve what is more commonly design principles in healthcare facilities, such as a hospital ER waiting room, which is typically 12 ACH and no recirculation, and up to a hospital operating room, 24 ACH, no recirculation. So your punchline or your takeaway here is ACH or equivalent ACH with disinfecting devices in the room can very easily be a universal measuring stick for anybody to compare any options that they're being presented with. Since the fundamental principle of safety here is I need to exchange potentially dirty air with cleaned air as fast as I can and many, many times per hour. Buckley team, there's a question thing flashing on my screen. As soon as I get done explaining this slide, I would like to know if there is a question and go ahead and address that. Before I do that though, I wanted to bring up or introduce to you what's called the Wells-Riley Airborne Infection Risk Model. As you can see on the bottom of your screen, the equation is fundamentally built around the fact that each time you double the dilution airflow, infection risk is roughly halved. So that was why this chart here on the y-axis had infection risk and on the x-axis has ACH. As you notice, every time I I double my ACH, my infection risk follows that curve of being halved. So this is how we can quantify how much more safe a customer's environment would be if we're able to achieve, hospital grade or healthcare facility grade ventilation as it pertains to airborne pathogens. Buckley team, is there a question that we need to go ahead and address?
Yeah, if you don't mind. Thank you, Keith. The first one was about the needlepoint ionization and bipolar. You were requiring, talking about different technologies. Needlepoint, he wants to know if needlepoint is bipolar ionization.
Yes, NBPI is technically the full name, needlepoint bipolar ionization. And that's the device that we're using and the technology in play here.
And then the next question is, can you compare and contrast ionization versus HEPA filtration?
I can, but I would want a more specific question. HEPA filtration has a similar ability, if done and applied correctly, to pull out, viruses or particles that are even as small as the coronavirus particle. So if somebody's asking me if I think HEPA filtration is more effective or less effective, the answer, as always, is it depends. If you apply either system appropriately, you can achieve the same results. So Christian Tabor is also on the line. Christian, anything you want to add there?
Well, I think fundamentally you're talking, the real question is, where is the disinfection or the dilution of pathogens being done. If you're talking about comparing HEPA filtration to in-unit ionization, I mean, the goal there is the same. What you're trying to do is remove any concentration of pathogens from the HVAC system. So, Keith, can you go back a slide? What you're attempting to do there is take your 1 ACH of outdoor air, so that's your dilution airflow in a typical HVAC system, and you're trying to make your supply airflow, which includes 3 air changes per hour of recirculated air, equally diluting. So with a HEPA filter, you're basically trying to go from 1 air change to 4 air changes. And with an induct ionization system, you're trying to achieve the exact same thing. You're trying to make the full volumetric airflow of the HVAC unit your dilution airflow. And that's a good thing. If you're going from 1 air change per hour to 4 air changes per hour from a dilution standpoint, you're having your risk twice. So if you started out high, you will be lower. The difference with the concepts that Keith is talking about is that they're in room. So we are not limited by the volume of the HVAC system. We're looking at more the volume of the airflow from the air movement devices in space. As a comparison, a single ceiling fan, residential ceiling fan will have roughly the same airflow as like a 5-ton rooftop unit, if not more. So, you're just looking at orders of magnitude larger airflow with an in-space system than you are with an in-unit system. Which is why you get those really high air changes per hour. Typical GUV applications, you would be looking at upper room GUV, be looking at an additional 12 to 24 air changes per hour for a properly designed system. So because you're not limited by the airflow through the ductwork. Hopefully that adds.
Thanks, Christian. Any other questions, Mike?
No, thank you very much.
Yeah, and to those submitters, whoever they were, thank you for asking the questions. We appreciate it. So let's switch gears. What I wanted you to take away from the prior few slides was, how do I compare options? What I submit is that air changes per hour, or exchanging, potentially dirty air with clean air, as it pertains to pathogens, is your easiest and probably most effective universal measuring stick. If you're looking at a portable air filtration device, like I hear a lot of schools talking about, and they want to ask me, what do you think about portable air filtration devices? I'm going to basically do some simple math. If I think that that portable air filtration device can capture all of the air volume in every corner of the room, floor to ceiling, not just the air local to the machine, and through the technology of that machine, I can achieve 12 ACH or 12 EACH, then I would tell that person that might be a good option. You're delivering the ACH that you want to make the space significantly safer. So I'm offering this to you as not a big ass fans measure of performance only, but help your customers understand that ACH is a very easy to understand universal measuring stick for comparing various investments. All right, we're gonna talk exclusively about upper room GUV for a moment, then we'll switch to ionization. As far as time, we are at 12:35, so we are okay. So number one, what do I need to know when it comes to looking at, researching, or applying an upper room GUV system? Number one, UVC, as we talked about earlier, is the wavelength. If you do any research on CDC, WHO, ASHRAE, all across the board, you'll see that 265, in that range of 265 nanometers, is the wavelength that we want to see for modern disinfection with UV. You want to make sure the product contains no mercury. Fortunately, Big Ass Fans is right on the bleeding edge of technology, so we use light emitting diodes, LEDs, instead of bulbs that contain mercury. So it's not an issue with our product. We are also a zero ozone certified device, UL 2998. believe that ASHRAE has very specific language about UL 867, UL 2998, et cetera, regarding what you can and can't do without certification for zero ozone. Old technology, old UV technology did create ozone. So it's just something to be aware of. I can't imagine there are any modern sales organizations trying to sell things that generate ozone. But I would imagine there are probably some people on Amazon or whatever who just don't care. Overall safety for ceiling fans, definitely UL 507. All of our products are tested, certified, listed UL 507. And then as a general application guideline for the fan itself, we like to see fans 10 feet above finished floor. The most important design criteria for an upper room GEV system, which would be inclusive of our fan and UV system, is that the UV output is above human line of sight. We are using, relative to UV induct options, we are using relatively lower intensities. So you would definitely have to stare at the light for a very long period of time for any sort of impact on the human eye or the human skin. But for that reason, we should not place fans with upper room lights above them in an application where essentially what you see here is possible. All right. Let's talk about how we go about doing the design. And this is where I will tell you, I want you to know that we do all of these steps, and essentially after step one, which is the general space dimensions and fan selection, that's as far as you need to go. All right. All you need to do is understand whether or not, one, I can meet the rules here. I don't have an application where I have an upper room system where there's maybe a mezzanine or a walkway or something where people can be looking down on the product. Two, once you understand the space dimensions and what people do in the space, Buckley can take over. So I'm not going to ask you to run any complex equations. This is where we take over and we do the following process. We are going to understand the layout of the room. We're going to understand how airflow is going to move around in that space, taking into account major obstructions to airflow. And first, we're going to be looking for a recommendation that takes control of the air and puts it into a continuous pattern that we want to see, which would just be your basic convection pattern, introducing airborne pathogens to the UV kill zone over and over and over again. There's a million things that we look at during this process, but that's why we exist, so just lean on us for those needs. The second thing is we'll define the disinfection zone, which is essentially the cubic volume that the UV lights will influence. The third thing is once I have that volume and the space dimensions and I understand how air is going to flow, I can measure essentially the dwell time, how long an airborne pathogen will spend in the UV zone. I can then calculate based on any, or not any, but based on the specific pathogen that we are talking about, I can tell you the EACH for the proposed solution. And then using that final piece, the Wells-Riley risk reduction formula, I can actually tell you how much more safe the space would be compared to a baseline. Here's what those steps look like. We take in the space details. We even need to know things such as the behavior of the occupants, meaning are they laying down taking naps on cots, or are they in a gym with a very high respiratory rate working really hard? We also can take into account existing HVAC systems, whether or not you have 2 ACH or 1. We can also take into account the number of infected sources. If you're in a particularly highly high positivity rate area, and maybe my default is to assume 1 infected source, but you want to see what your risk would be if there were 3 infected sources, I can take into account those details. Using this, we're going to run what's called a CFD analysis, and that's a proprietary software. CFD isn't proprietary, but our software that Buckley and Big Ass Fans team uses, we'll run a CFD analysis and make sure that we're getting the right particle flow, the right airflow patterns. And one of our first measures of a successful design is in a UV system is achieving 25 zonal air turnovers per hour, which essentially means I exchange the air that the UV is influencing with the breathing zone or the air below it. If I can exchange those 25 times an hour, that is where you essentially start reaching diminishing returns. So 25 is our design standard. The next thing I do is using what's called the IES file, or the Illuminating Engineering Society file, which tells me in a lighting simulation software the pattern and intensity of that light distribution. I can model that in any space and tell you how much area will be influenced by UV and how intense it will be while it's in that area. Then I can combine those two things, tell you how many times and how long the pathogen will pass through the disinfection zone, and then using what's called the K value, which is a variable which quantifies a particular virus's susceptibility to being inactivated by UV. I can tell you that, for example, with this design, I can eliminate 99% of tuberculosis in a certain period of time. So that's the effectiveness of the system. I can equate, because I'm pulling X amount of CFM through the fan and I'm mixing it a certain number of times per hour, and now I know the impact of my UV in there as well. I can tell you what the equivalent ACH is, and I can then turn that into a Wells-Riley equation. This is how we put it all together on one slide. We take the customer's application. This example was a small sort of a strip mall fitness application. I take into account major obstructions to airflow. I make a fan recommendation to get the convection patterns that I want. In this example, it was 4 overhead 52-inch UV fans. I can validate that I have the patterns that I want using the UV that comes on each fan. I can run my models on various airborne pathogens such as SARS, influenza, tuberculosis, the rhinovirus, etc. And what I can tell you is this design running in the forward direction based on the respiratory rate of the occupants, all of these things will result in 12.1 EACH on SARS-CoV-1 as an example, which is a greater than 90% risk reduction, which obviously means that this is a highly effective system and significantly safer to be in this space with the option that we proposed compared to some others. Okay, so this is how it all comes together, and this is what Big Ass Fans will deliver to you and your customer. We'll make sure we run all these models, we'll explain it, and we'll advise the customer on what we're capable of achieving as it comes to risk reduction. All right. Once again, you know that you're going to lean on us, right? You don't need to be an expert. You don't need to know all the calculations. I highly doubt that you all wake up every day and want to design fan and UVGI systems, you know, one at a time. But that's why we exist. You know, you lean on us to help you through those steps. We will do them for you. We will make sure you and your customer understand all of the pieces. All right. So air ionization is our next topic. I promised 10 minutes and I've got 5 minutes left. The good news is this is pretty quick and easy. Ionization, we're going to start with safety. Old technologies such as corona discharge tubes, they created ozone. First and foremost, look for products that have UL 2998 that create zero ozone. Our product is also UL 867 certified for electrostatic devices. And then typically, if you are in an environment where there are combustibles, such as Houston, Texas, and the oil and gas industry, this is an electrostatic device. So that would be an application where I would sort of proceed with caution with the assistance of big ass fans. All right. We are going to very briefly talk about ionization compared to, or big ass fans ionization options compared to an induct system. The easiest way to think about it is, number one, I need a high concentration of ions to make an immediate impact or a rapid impact. And two, I need them everywhere, all right? A lot of classrooms, they may have one supply register in the far corner, one return register in the near corner. And if you put an ion device in the air handling unit, you may get decent ions over there by the supply register. But you're not just trying to keep the 3 students under the supply register safe, you're trying to keep the whole classroom safe. So what I would encourage everyone to do is, as you compare our option to an induct option, ask for how many ions I'm going to get and where are they. Those 2 things should definitely be something somebody considers as they compare the effectiveness of induct options compared to in-room options, all right? Induct definitely has a place. They're highly effective at keeping keeping things from transmitting room to room. And they're also highly effective at keeping coils clean, reducing maintenance, extending equipment life, etc. But they are not the same performance, if you will, as an in-room option. So we're going to look at real-world examples because they do speak for themselves. And in 3 minutes, we're going to open it up for questions. The first example I'll show you is 3 fans that we installed in a corporate hangar in Florida. It was 35 foot tall. And as you can see, with the fans running at 50%, we were able to create and deliver on average 33.7 thousand ions, or 33,000 negative ions per cubic centimeter as we took measurements all over the space. So that was the average. And just for clarity, the negative ions are more impactful when it comes to the germicidal effect. So that's the column that I would consider to be most important. At 100%, full speed in May, June, and July, they're going to get 47,000 ions per cubic centimeter. So definitely in that, definitely correlates to the test that I showed you in the very beginning, where I showed you that with an ion concentration of 40,000 ions per cubic centimeter, you can see rapid inactivation and 5 log reduction in the first 60 minutes. What I'll also share with you here is this customer was very open with us. They got an estimate for DOAS units to try and bring in essentially the same amount of outside air to achieve the equivalent ACH that we achieved here. Our solution was 1/5 of the cost, and on an ongoing basis, because our fans are only 1.5 or 2 horsepower motors, we are 1/6 of the energy annually that those systems would have used. So equal or better effectiveness, lower upfront cost, lower ongoing cost. Second application was ionization again. This was a fitness club. Their corporate colors are purple and yellow. You probably see them all over Big Ass Fans website. It was a 20-foot tall space. We achieved 93% infection risk reduction. At 50%, 52,000 ions, and at 100%, 82,000 negative ions per cubic centimeter. What we also did for this customer was they understood that, we were a no ozone certified device, but just to make sure they understood, we actually measured for ozone the entire time we were there, and 0 ozone was detected during the entire process. The last 2, these are UVC. Orange Theory Fitness is a company that has absolutely harnessed air disinfection as a differentiator from their clubs to their competitors. In this example, with the 8 Haiku UVC we installed in this application, we were able to achieve a total ACH of 46. So remember back in the slides earlier, hospital operating room is 24. We are damn near double a hospital operating room as it pertains to pathogen ventilation. 93% reduction in the risk of coronavirus transmission for a member. And then last but not least, here's a high school. They had 2 areas they wanted us to work on, the gymnasium and a common area. We installed UV products here. And as you can see in the gym, we reduced infection risk by 95%. We reduced infection risk in the common area by 83%, and achieved, 19.1 ACH in that gymnasium. We want you also to recognize that if you invest in these technologies, it is still on the customer to promote to everyone that they've spent the money on something that's extremely effective. So Big Ass Fans has already created posters, banners, window stickers, table toppers, everything you can imagine that would help a customer understand that your business is safer than the one down the street. And then last but certainly not least, we have been featured on multiple news channels. Not we meaning Big Ass Fans, but Upper Room GUV or UVGI has endorsed by the CDC. So guys, this is taking a lot of attention, or getting a lot of attention in the media. And these are highly effective solutions. They're all backed by science. We can back everything we say with third-party testing or real-world validation. So I would definitely encourage you to ask questions and learn more. So with that, Buckley Associates, let's open it up and see what questions this group may have.
Thank you, Keith. Again, if you have any questions, if you want to go ahead and answer now, we have a few minutes to answer any questions. Right now, Keith, I don't see any questions that has been asked at this time. We can give it a couple of minutes for anyone.
Yeah, I don't mind. Yesterday, it was about a minute before someone typed something in, so we will not share.
Like slow fingers.
Yeah.
So
we will not share who asked the question, so we'll just repeat it anonymously. So if anybody has any questions, don't be shy.
Thank you, Keith. I will kind of hang on here. I hope everyone enjoyed the presentation today. And if you have any questions relevant to the topic that was discussed or any other products Buckley has, feel free to reach out to us. And again, if you're not sure who your Buckley representative is, get a hold of Sherry. She'll get you in contact with the proper person in our office. We do support the manufacturer's products that we represent, all the way from the design phase, all the way through the sale process and final commissioning. We have a good relationship with Big Ass Fans. They are very good at designing your system of what you need to make sure that it works as they say they do. They're really good at that. Also, we support them in any way that we can. If you reach out to us, we'd be glad to help you with that. We also have a service department that's certified on all of our products for startup commissioning. They're fantastic to work with, and they can help you diagnose any problems or anything that you have. I want to thank excuse me. I want to thank everyone that put this together, and I want to thank everyone that's on attendance here. Appreciate your time. And again, if you have any questions, please reach out to us. I'll wait a couple more minutes and then we can, we'll close her out, Keith. Great job. We appreciate you.
Thank you. We're here for a couple more minutes.
We have one other question here. Is the bipolar ionization needle point, is it a good product to retrofit existing fans?
Of the two questions that were asked yesterday, this was one of those questions. So I'll probably need to start covering that. Yes, the good news is several Big Ass Fans models that have been sold in the last few years can be retrofitted with either a UVC option or a bipolar ionization option. A lot of our biggest customers, Amazon, FedEx, Toyota, Walmart, a lot of them have already started the process of retrofitting many of their fans across the country. So yeah, depending on the model, let's get a picture of it. Let's understand which model it is. And then maybe we even need to come on site. That's why Lane and the Buckley team is here to help. we potentially can retrofit, yes.
Awesome. Thank you. Anyone else have any questions that they would like to ask Keith or while we have? Oh, we have one here. Does the ozone generate both positive and negative, or positive and negative ions generated simultaneous? How are they kept apart?
The word ozone was used. Was that a slip up, or did the person ask ozone?
Yeah, the person asked, but I think what they're the positive and negative ions, I think I'm going to interpret this and let me know if I'm incorrect, is how are they generated simultaneously, positive and negative ions?
Yeah, I mean, basically as air flows over the needles, the air sort of pulls off both positive and negative ions from those two needle points on the device. So it's not a matter of single polarity as a device, if you will. So I don't know if they're Christian, if you want to be any more specific. He might have had to run.
Yeah, sorry, that is not something I'm knowledgeable on, is the exact how they're generated. Sorry.
Well, let's see. Has testing been done with the needle point by bipolar ionization and UVC used in the same space?
No, but I don't know why it would be necessary. I mean, they are certainly proven to be effective independently, and yes, their benefits would be additive. UV will disinfect air that comes through the UV zone, and ions can disinfect anything where I can get ions. So we do have customers that are using both technologies. Actually, a lot of our sort of preschool, kindergarten, daycare sales have been the combination of upper room GUV and ionization for that exact purpose. And I think everyone should know too is there's no one silver bullet. All right, the only silver bullet is just stay home. So once our world agrees that we're not just going to stay home, then the next question has to become, okay, how close can I get to the safest possible environment? And the answer really is, I have to do many things. I should probably be wearing a mask. I should consider getting the vaccine. I should wash my hands. If it's a restaurant or a bar, let's make sure we're not within 6 feet of each other. And then, let's also clean surfaces. Let's also clean the air as good as we can. So there's no one silver bullet for everyone. Just spend your money here and we can all just go back to normal. It's a matter of, it's just like getting in your car when you drive to work. You're taking a calculated risk. There's actually a relatively high likelihood that you could get in a car wreck on the way to car if you run the math. So I would encourage you guys to help your customers understand this is a piece of a larger behavioral change and a larger system of behavior to be safe.
Thank you, Keith, for that answer. Okay, it's 1 o'clock. You guys have any other questions, feel free to send them in. We'll make sure to get them answered. Or if you have any projects that you're working on, we'll be glad to help. And if we need to get Big Ass Fans involved, which we normally do, we'll get with you so we can get this project going as smooth as possible. One thing I really want to mention, Jason Butler is the product specialist. And if you see on your screen, you'll see his email there along with Lane. Feel free to reach out to them with any questions you have as well. Or you can get with Sherry again, and she'll get you in touch with your Buckley representative. I want to thank everyone for attending. And again, I want to thank Keith for the awesome presentation you did. We appreciate it.
Likewise. Thanks, everyone. Have a great day.